Okay, let's look at the definition of a factorial or an exclamation mark. Factorial, the product of the consecutive numbers from n to 1. Let's see some examples. So, 5 exclamation mark. What does that mean? Well, it means that number times every number below it till you get to 1. So 5 times 4 times 3 times 2 times 1. And yeah, we can take out the calculator, but 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So 3 factorial is simply just equal to 3 times 2 times 1. So what would n factorial in the notes off to the right? N factorial, n exclamation mark. Well, it means it times 1 minus 1 times it minus 2, and so on until we get down to 3 times 2 times 1. Now, for the purpose, it doesn't really matter what we get to 3, 2, 1. We're going to cancel them off anyway. So let's see how canceling works. So let's take 7 factorial over 4 factorial. Now this is tedious, so it's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. And I have a 4 on the top and a 3 on the top and a 2 on the top and a 1 on the top, so it's just simply 7 times 6 times 5, which is equal to 210. So a little bit later, we're going to learn how we can close the factorial and simplify this process. A couple things to watch out for. First of all, negative 3 factorial is just equal to a negative with 3 times 2 times 1 after it, equaling negative 6. Now, we cannot have a negative 3 all factorialed. No solution, does not exist, whatever you want to call it. We also can't have a decimal or a fraction factorial. No solution, does not exist, whatever you want to call it. So, a little bit more. 0 factorial. Well, that one's weird. So the earlier definition I gave you, sure, it's a definition. Another definition is how many different ways can you choose 0 objects from 0 objects. And the number of ways you can choose 0 objects from 0 objects is 1 time. Philosophy class. There's one way you can choose 0 objects from 0 objects. 1 exclamation mark, 1 factorial is just simply 1. 2 factorial, 2 exclamation mark is simply 2 times 1 equals 2, and 3 factorial, we did above, is 3 times 2 times 1, and lots of times you can just do it in your head. Further in the notes, 4 factorial, 5 factorial, 6 factorial, 7 factorial, etc. A little bit off to the right, so earlier in the notes, I'm going to draw a red arrow down, we did n factorial. Well, what does n plus 1 all factorial mean? Well, it means itself, always starting with whatever you see, times 1 less than that, times 1 less than that, etc. all the way down to 3, 2, 1, which rarely comes up. That probably got cut off by the video. So, check it out in the notes. You can see a lot more examples like that. Now, we're going to continue on the same page of notes, learning how we can close the factorial anytime we want to. We're going to see why that's useful. So let's go for 6 exclamation mark. Well, we learned earlier that that's 6 times 5 times 4 times 3 times 2 times 1, as you can see above in the notes. But let's say, for example, I want to say 6 times 5 times 4, and I want to close the factorial right there. Let's do it. We can close the factorial anytime we want to. We're going to see why it's going to be useful soon. So let's take something like 10 factorial. So that's 10 times 9. Let's close it right there. In the notes, we've got 99 exclamation mark. Close the factorial anytime you want. Let's take n factorial. Well, that's n times n minus 1, always what it is, times 1 less than it, times 1 less than that. And let's close the factorial there. As you can see in the notes, we did a bunch more examples like that. Now let's see why it's useful. So let's say I have 7 exclamation mark over 4 exclamation mark. The same example we did earlier on this page. Well, that's 7 times 6 times 5 times 4. Now I could continue, or I could close the factorial, which is over 4 factorial. Now, why would I want to close the factorial on the top? Well, because I can cross off a 4 factorial from the top and the bottom, and 7 times 6 times 5 is, like it was before, 210. So let's see another example of closing the factorial anytime we want to. Well, let's take n factorial over n minus 2 factorial as seen in the notes. So I'm going to expand the bigger one. Notice it says in the notes all of these things. You may close the factorial anytime you want, above in the notes. Down below, expand the bigger one. We really want to learn these sentences. So what's bigger, n or n minus 2? Well, n is bigger because if you subtract 2 from something, you get smaller. So we're going to expand the bigger one. So if I expand the top, I start with what it is. Then I do 1 less than that. Then I do 1 less than that. Then I notice it's on the bottom. So I close the factorial over the same thing. And I have an n minus 2 factorial on the top and the bottom. So I can cross them off. Lots of the times they're going to be going down. I'm just going to the right because it saves some space. So I could distribute, but if I distributed, I'd have to refactor, and I'd rather just leave it like that. There's going to be other types of examples. Adding and subtracting fractions. Let's take 10 factorial minus 9 factorial over 8 factorial. 8 factorial. Well, I know that I can add and subtract fractions. I know a minus b over c is equal to a over c minus b over c. And by now we should be able to go back and forth between adding fractions with the lowest common denominator and separating fractions with the lowest common denominator, so we can separate. So I have 10 exclamation mark over 8 exclamation mark minus 9 exclamation mark over 8 exclamation mark. And I didn't finish it off in the notes, but I've got some space here, so I'm going to, and I'm actually going to go down this time, the place I'd rather actually go in the notes. So now I'm going to work on this 10 factorial on the top here. So that's going to be 10 times 9 times 8, and then I notice the 8 factorial on the bottom, so I decide to close the factorial at that point. Over 8 factorial. I have an 8 factorial on the top and the bottom, I can cross them off. Then I have minus, and then I'm going to go 9 times 8 factorial, and I can close the factorial again, and I can cross off the factorials from the top and the bottom, which is simply just 10 times 9 minus 9, which is 90 minus 9, which is 81. So what looked initially difficult was actually a lot simpler. Notice we can't just start crossing exclamation marks all over the place off the top and the bottom. We have to do appropriate, off to the red, big red, separating fractions, or proper expanding of these factorials in a useful fashion. So these exclamation marks, these factorials, we're going to be working a lot with. Notice the top, big red, 6 times 5 times 4. We saw that in the last section on the fundamental counting principle, multiplying the number of things that we have together to get the total number of ways we can arrange those things. Let's take a look at some more examples.